All right, chemistry, let's do the second part of our video lecture for the combined section of Chapter 5, Sections 1 and 2. Now we're going to talk about electron configuration and the periodic table. So in Chapter 4, we spent a lot of time talking about electron configuration. Last lecture, we talked about the periodic table. Let's combine them and see how they work together. So in this lecture, I want you to be able to describe the relationship between electrons and sublevels and the length of each period of the periodic table. Remember, period is a horizontal row. Locate and name the 4 blocks of the periodic table and explain the reasons for these names. Discuss the relationship between group configurations. Remember, group is a vertical column, and group numbers. Describe the locations in the periodic table and the general properties of the alkali metals, the alkaline earth metals, the halogens, and noble gases. These are a few of the more notable categories within the periodic table that we've actually already discussed and colored on your periodic table in class. Let's get started. Now, at the end of this lecture, I want you to be able to answer these 2 types of questions. Right? We're not going to do this right now. We're going to do it at the end. But without looking at the periodic table, I want you to be able to give the group, period, and block in which the element with the electron configuration xenon 6s2 is located. All right, so for that element, I want you to be able to give me the group number, the period number, and the block. And then secondly, without looking at the periodic table, again, without looking at the periodic table, write the electron configuration for the group 1 element in the 3rd period. Is this element likely to be more or less active than the element described in number 1? Right? So that's what we're going to do at the end here, is what we're working towards. So let's start with the S block. Okay, these are the highly reactive metals. They are composed of groups 1 and 2. Okay, the picture's over here. Group 1, group 2, and helium. Don't forget helium. So we actually have to throw helium up here because it is truly an S block element. Okay, I know that on your periodic table it's placed over with the noble gases because helium is a noble gas. That's very true. You got to realize when the periodic table was really being fine-tuned, there was a choice to make. There was gonna be some sort of annoying exception one way or the other. But the question was, do we want to place helium in the group with other elements that are chemically similar, which is what the periodic table likes to do, or do we want to put it in the same block as hydrogen, which it actually is? Do we want to place it over there in group 2 so that you can easily see it's in the same block? They decided to put it over with the noble gases, so that's fine. But that's all the S block elements in groups 1 and 2, including helium. If we look at group 1 specifically, right? Okay, all of these elements are going to be S1 as far as their electron configurations are concerned. Okay, it might be 1s1, it might be 2s1, it might be 3s1, it might be 4s1, 5s1, 6s1, 7s1, but they'll all be S1 because there's only 1 electron in the s orbital for these elements. Because there is 1 electron in that outer energy level, it's going to easily lose that 1 valence electron, meaning outer electron. Also, these elements, they react violently with water, and they react with the halogens to form salts. Now, salt, not like the salt that you put on your food. I mean, that is a salt, but that's table salt. It's a specific type of salt. There are several types of salt. Salts just refer to anything that's ionically bonded, anything that bonds something from the left side of the periodic table to something on the right side of the periodic table. That's considered a salt. All right, group 2, okay, the alkaline earth metals, okay, these are all going to be S2s, right, because we have a second electron. So it might be 2s2, 3s2, 4s2, 5s2, 6s2, 7s2, but it's always going to be an S2. So they're going to easily lose these 2 electrons to form positive ions. These elements in general are harder, denser, and stronger than group 1 metals. They also have higher melting points, and those 2 things are actually pretty related. They are less reactive than group 1, but they're still very reactive. They're too reactive to be found in nature on their own. You never find a pure sample of calcium. It's always going to be bonded with something because it will have reacted long ago. Let's move to the D block, the transition metals. Okay, this big middle chunk of the periodic table, composed of groups 13 through 12. Okay, what did I say? 13. Sorry, 3 through 12. Group 3 through 12. Transition metals are what you think of when you think of typical metals. Okay, like shiny. They have quite a bit of luster. They just look like metals. They seem like metals. These are called transition metals. Okay. Pblock, moving over to the Pblock, the right side of the periodic table. The Pblock consists of groups 13 through 18. Okay, the Pblock and Sblock elements are collectively known as the main group elements. Remember when we were talking about the octet rule? We made kind of a big deal about the 8 electrons that fill the S and the P sublevels. Well, the S and the P sublevels are kind of a big deal, and we call them the main groups. Okay, the main groups. So there are 8 main groups, even though there are 18 groups. So what does that mean? Yes, all of these groups in the middle, 3 through 12, are not considered main groups. They are not main. Okay, they are not main. So if I say main group 3, I'm not talking about group 3. I'm talking about boron over here on the right side. So these are the Pblock elements. They are made up of the metalloids. Okay, we have the metalloid staircase right here. We have all of the nonmetals over here as well, with the exception of hydrogen and helium, even though those are nonmetals. But we have the Pblock nonmetals. And then we also have a couple of Pblock metals down here, like gallium, indium, thallium, lead, and bismuth. We already mentioned, I already mentioned the non-metals, okay, on the right side of the periodic table, and consisting of the halogens, noble gases, and the rest of the non-metals. Okay, they're in the P block, composed of the elements to the right of the metalloid staircase. And so some of the most important groups within there, the halogens and the noble gases. We already talked about the halogens. Okay, those are elements in group 17. They are the most reactive elements out of all of the nonmetals. Okay, out of all the nonmetals over here on the right side in the P block, the halogens are the most reactive. They combine with metals to form salts. Remember when we started this whole shebang, we talked about elements over here on the left side of the periodic table bonding with halogens to form salts. Goes the other way around. So let's talk about the noble gases. Those are comprised of the elements in group 18. They are the least reactive metals out of, the least reactive elements out of everything on the periodic table. Okay, they are stable because they do not react. That's what it means to be stable. You do not interact with other elements. That's also typically why people call them noble gases, because they don't interact with the lesser elements, quote unquote. But that stability that the noble gases have, it stems from a special electron configuration. We've already talked about that a little bit. They have a full octet. Their S and P sublevels are completely full. They have all 8 electrons in those sublevels combined. When you have a full octet, when your S and P sublevels are full, you are said to have a full valence shell. Those are your highest energy electrons, and those are referred to as valence electrons. So if your outer shell is full, your valence shell is full. So valence here is really only referring to our outermost electrons. Now the P block has a lot of the nonmetals, but it also has some metals. Okay, any of these metals to the left of the metalloid staircase, these are called P-block metals. So aluminum, gallium, indium, thallium, lead, bismuth. These are all metals. Okay, these are all metals, but they are in the P block, so they're called P-block metals. They are very similar to each other. Chemically speaking, they're very similar to other metals. The only difference really is that they have at least 1 electron in their P block. That's pretty much the only difference. So P-block metals. All right, so we're getting close to the end here. Let's see if we can carry out our goal of being able to answer these 2 questions. Again, without looking at the periodic table, give the group, period, and block in which the element with the electron configuration xenon 6s2 is located. And then without looking at the periodic table, write the electron configuration for the group 1 element in the 3rd period. And then is this element likely to be more or less active than the element described in number 1? Let's give it a shot. So for number 1, xenon 6s2. Well, I can tell that it is group 2. Why? Because there are 2 electrons. And again, this is the information I'm looking at right here. 2 electrons, superscript 2, 2 electrons. If it's got 2 electrons, it's going to be in main group 2. I can also tell from this information that it's going to be in period 6. Why? Because of the 6 in the 6s2. Right? So 2 electrons in the 6th period. And what block is it in? In the S block. Again, you get 3 pieces of information from 6s2. And those are them. You get the block, you get the period, and you get the group number. All right, last question to answer here. Let's see. We are looking for the electron configuration for the group 1 element in the 3rd period. So it's a 3rd period. N is equal to 3, right? So in order to get to N equals 3, that means that the 1s, the 2s, and the 2p sublevels have been completely filled in order to get to N equals 3. Makes sense, right? Now it's group 1, so that means that there's 1 electron. Okay? So we're going to have the general form of something S1. So I have N here just as a variable. So it's going to be N S1, something S1. Now we just established that it's going to be, the N value is 3. So our highest energy electron is going to be 3s1. Okay? Group 1, there's 1 electron. The 3rd period, so it's 3s1. So we're going to write this electron configuration one of 2 ways. If we use the full-on electron configuration notation, it's going to be 1s2, 2s2, 2p6, 3s1, or neon 3s1. All right, so noble gas configuration. All right, what have we done so far this lecture? We've described the relationship between electrons in sublevels and the length of each period of the periodic table. We've located and named the 4 blocks on the periodic table, and then we examined the reason for those names. We've discussed the relationship between group configurations and group numbers, and we've described the locations in the periodic table and the general properties of the alkali metals, the alkaline earth metals, the halogens, and the noble gases. All right, guys, I will see you next period.